our second problem is going to be 33 and 714 thousandths divided by 9. Luckily, we know our nines times tables. If we don't, we always have a multiplication table that we can look at. So we really don't have to do much as far as knowing our multiplication tables, because hopefully you learned those in 3rd grade. If you didn't, you have the access to your multiplication table in your journal. First thing we do is we move our decimal points straight up. My decimal points between the ones and the tenths. Second thing is we're going to work through each place value one at a time. Does 9 go into 3? No. I'm not going to have a number above the tens place. Does 9 go into 33?
No. Yes.
Yes, it does. Which means that I'm going to have a ones place, tenths, hundredths, thousandths. How many times does 9 go into 33? Bueller? 3 times. 3 times 9 is? 27. Thank you for waking up. 13 minus 7? 6. Then I bring down my tenths place. I get 67. How many times does 9 go into 67? 7 times. And 7 times 9 is? 63. 67 subtract 63 is 4. Bring down my 1. Does 9 go into 41? Yes, it goes in, not evenly. How many times? 4 times. And Keegan, you were saying 36, because 4 times 9 is 36. And 11 subtract 6 is? 5. Bring down my 4. And how many times is 9 going to 54? 6 times. Good job, Wesley. 6 times 9 is 54. Subtract, I get 0. I have nothing to bring down. I have 0 after I subtracted. Now I do not have to add anything and keep going. But because your teacher's a jerk and wants you to check your work by multiplication, which is the inverse operation, we're going to take our quotient, which is 3 and 746 thousandths. We're going to multiply it by our divisor, which is 9. If we did it correctly, then my product should be the same as my dividend. If I did it correctly, I should get 33 and 714 thousandths. So let's check. 9 times 6 is 54. Put my 4, carry my 5. 9 times 4.
36.
Plus 5.
41.
41. Carry my 4. 9 times 7.
9 times 7. 63.
63 plus 4.
67.
67. Carry my 6. 9 times 3.
18. 27.
27 plus 6.
33.
33.
And
Now I'm going to go back and I'm going to look in my problem. Look at each of the factors. In this factor, how many numbers are behind the decimal point?
3.
3. In this factor, how many numbers are behind the decimal point?
0.
0. Which means if I add those together, that's going to tell me how many numbers are behind my decimal point in my product. And since there are 3 behind the decimal point in the problem, there has to be 3 behind the decimal point in the answer. So I have 33 and 714 thousandths, which matches my dividend up here, which means we did it right. Thank you, Jaden.